Imagine if the device you're watching this explainer on right now was so massive it literally needed its own zip code. Crazy, right? Well, today we're tracing one of the absolute most mind-bending engineering journeys in human history, a relentless, almost obsessive push to shrink the computer. We're going to explore exactly how we went from these heat-generating, room-sized behemoths to the incredibly powerful pocket-sized devices that, let's be honest, we rely on for absolutely everything today.
Just to put the sheer scale of this change into perspective, think about the ELEC, which was publicly introduced back in 1946. This thing weighed 30 tons. It took up an entire room, and it was built purely to crunch huge numbers. Now, compare that to a modern smartphone. It fits effortlessly in the palm of your hand, yet it packs millions of times more processing power than that whole room-sized giant. That one dramatic shift in physical size completely rewired how our entire world operates.
So here's our roadmap for today's explainer. 1. The room-sized giants. 2. The great shrink. 3. Computers in your pocket. 4. The double-edged sword. And finally, 5. The AI frontier.
Let's kick things off with Section 1, the room-sized giants, vacuum tubes, and early computing.
Now, the actual backbone of these early giants was something called the vacuum tube. Machines like the ENIAC and the UNIVAC I, which, fun fact, was first used by the U.S. Census Bureau in 1951, were incredibly powerful for their time. But they had a pretty massive fatal flaw. They were huge, extremely fragile, and they ran so hot they were just constantly burning out. Honestly, operating them was practically like managing an industrial furnace. You had to rely on punch cards and paper tape just to get them to do anything. They were these massive, unwieldy installations, definitely not something you'd buy at a consumer electronics store.
But alongside all that clunky hardware, a really vital conceptual leap happened. See, before 1949, if you wanted a computer to do a new task, you literally had to physically rewire the machine. Physically unplugging and moving thick cables by hand. Then came the stored program concept, and it changed the entire game. By keeping both the instructions and the data directly inside the memory, a single machine could suddenly run tons of different applications. It was our very first big leap in making computers physically simpler and infinitely more versatile. It really laid the total groundwork for all the software we use today.
Moving on to Section 2, the great shrink, transistors and integrated circuits. If you look at the timeline of computing, it's honestly a testament to human obsession. Over just a few short decades, we rapidly solved those massive physical size and heat problems, generation by generation. You've got vacuum tubes in the 40s giving way to transistors in the late 50s, integrated circuits in the mid-60s, and finally, microprocessors in the 1970s. Let's zoom in on that incredible leap for a second. Second-generation transistors were the things that finally killed off those hot, bulky, fragile vacuum tubes. They made computers faster, a lot more reliable, and critically, way smaller. But the real magic trick? That happened with the third generation, integrated circuits. Instead of meticulously hand-wiring all these individual parts together, engineers figured out how to practically print countless electronic components onto a tiny single chip of silicon. It was brilliant. They made production drastically cheaper, cooler, and the physical footprint radically smaller. Which brings us right to Section 3, computers in your pocket, the microprocessor revolution. So the year is 1971, and Intel releases the 4004 microprocessor. This right here was the holy grail of our whole shrinking narrative. It took the entire central processing brain of a computer and slapped it onto one single fingernail-sized chip. This is the direct ancestor of almost all your modern tech. Because of this tiny little square, things that used to be pure science fiction like personal computers, graphical interfaces, and eventually the smartphone actually became a tangible reality.
It's honestly wild to stop and really think about it. What actually happens when a room-sized supercomputer shrinks enough to fit right in your pocket? Well, it escapes the confines of government labs and university basements, and it absolutely takes over our daily lives.
Because the hardware essentially vanished into our pockets, information and communication technology, or ICT for short, integrated into literally everything. Think about a typical day for a second. You send a message across the globe in milliseconds. You collaborate with coworkers who are miles away using remote databases. You pull up your digital health records instantly, or, just shop globally right from your couch. The shrinking of this hardware completely, entirely rewired how modern society functions.
But of course, we have to look at Section 4, the double-edged sword, the impacts of ubiquitous technology.
Obviously, we can't deny the massive, uplifting benefits of this shift.
This tiny tech has empowered us with absolutely incredible tools for creativity and productivity. I mean, it gave us instantaneous, cheap access to essentially the entirety of human knowledge. It helps public transport and governments handle vast amounts of data efficiently. And it's completely reshaped the global economy, right? Creating entirely new career paths in programming, data analysis, and cybersecurity that didn't even exist just a few decades ago.
But you have to contrast that with the real human risks that we now have to actively manage. Having a supercomputer constantly pinging in your pocket, well, it can lead to way less face-to-face interaction, not to mention significant sleep disruption from all that excessive screen time. And as this tech automates more and more tasks, we're facing real job displacement. Plus, we've all seen the rise of privacy risks and the rapid spread of misinformation online. Furthermore, this incredible tech isn't free. There is a harsh digital divide out there, leaving those without access or reliable internet connectivity falling far, far behind. Because at the end of the day, this tech is really just a tool. Its impact relies entirely on us. And that's exactly where digital citizenship comes in. It means actively protecting your personal data and actually verifying information before you just blindly hit retweet. It means treating others with respect in online communities. And honestly, most importantly, it requires purposefully balancing your screen time with physical exercise and real-life in-person relationships. We have to use these pocket supercomputers to solve problems, not create harm.
And that leads us to our final stop, Section 5, the AI frontier, the fifth generation of computing.
Now that we've practically mastered shrinking the physical hardware down to next to nothing, this fifth generation shifts the focus entirely. We are now expanding the mind of the machine. Practical AI isn't some distant sci-fi research goal anymore, it is already here. You see it every day in the speech recognition and natural language algorithms on your phone that actually understand how you talk, and in expert machine learning systems designed for incredibly complex problem solving.
But here is a really vital reminder from our sources today. No matter how microscopic, how fast, or how smart the computer gets, it will absolutely never replace the need for responsible human judgment. These systems are incredibly powerful, for sure, but they are completely, 100% dependent on strict data quality and our own human oversight to function safely and effectively.
So, I'll leave you with this provocative thought to chew on today. We've traced this impossible journey from massive, burning hot vacuum tubes in giant rooms all the way down to microprocessors in our pockets and now into the realm of artificial intelligence. Out of all these incredible leaps we've explored in this explainer, which single invention do you believe changed our society the most? And where in the world will the next great leap take us?